Graphing tangent assignment. In our unit, we've explored the graph of sine and cosine extensively. And so what we want to talk about is the tangent graph. We haven't done any work with the tangent graph at all. So this is just an exploration of that. The tangent graph fits because it's one of our trig ratios. And the other reason why it fits is it's also periodic, just like sine and cosine, which means it repeats in regular intervals. It has a pattern in regular intervals called cycles, and the length of those cycles is called a period. So what we're going to look at is we're first of all just going to start to create this, and we're going to see what does it look like, and then we're going to ask that you do a couple graphs on your own paper by hand. So let's make a XY table so that we can look what this graph is. And so our input, let's use that as theta, and our Y value, let's use that as what that ratio is. So we'll make a little table like this. Sorry about the squiggly lines. And let's start with what do we know about the unit circle? So let me just do something here. Let me bring our unit circle in here. And what I'm going to do is you can have your unit circle out. That would be great. I'm just going to take a photo of this. I'm going to drop it in here. That way we'll have something to, that'll give us some values here. So when we make our table, we aren't guessing. All right, so what do we know about tangent? Well, tangent's a little bit different. Tangent is the sine over the cosine, so it's the Y value over the X value. So let's start here with 0. Let's just do tangent from 0 to 2 pi. Let's do one revolution and kind of just see what it looks like. So we'll start here when it's 0 radians. 0, the angle of rotation is 0. So at 0 radians, the tangent is 0 over 1, or Y over 1. 0 over 1 is 0. Okay, let's move to here. So let's just do that at each of these increments. So we'll go to this value, root 2 over 2 over root 2 over 2. When we have that, when we have the same number, root 2 over 2 over root 2 over 2, these values basically just cancel, and that's equal to 1. So that's at pi over 4. So we're just going to create a list of values here. Let's go another 45 degrees. So this is 1 over 0, the Y value over the X value. This is undefined. So, and that's at pi over 2. It's undefined. That's interesting. I wonder what that's going to look like on a graph. I bet we can remember that from rational expressions. Undefined are asymptotes. So we'll just put a little of that. All right, that's going to create an asymptote there, a value that it reaches but never touches. All right, let's go to here, 3 pi over 4. Now, if we know anything about the unit circle, we know that if these are the same, but one of them is negative, then this is going to be the opposite of 1. It's going to be negative 1. So it looks like we have a bit of a pattern going on here. Let's go to pi. And we have 0 over negative 1, which is 0. Let's go down here to 5 pi over 4. Again, we're just kind of creating the just a few of these 45 degrees just to see what the graph looks like. Maybe it's similar to sine and cosine. I don't know. So negative root 2 over 2, negative root over 2, same value. They cancel out. They're both negative, so it's positive. Then we're down here, 3 pi over 2. And at 3 pi over 2, it's negative 1 over 0. That's undefined. So that means there's an asymptote there. Almost done. Let's go to 7 pi over 4. 7 pi over 4, it's negative 1. You can see we got a little pattern here. And then finally up here, this is 2 pi. That's our final one. And that should be enough to see if this thing, where it repeats and maybe find its period or what the cycle length is. At 2 pi, it's 0 over 1, which is 0. Okay? All right, so let's get rid of this for a second. Let's clean up this. Now what we want to do is let's just start to create what this graph is going to look like. So what I would ask that you do, let's go like this. Let's make a, we'll make a axis here, and then let's make another one right down the center. go out to here. And then let's kind of label these. It's really important for us to label these values. So our x-axis is theta in this case, and our y-axis is tangent theta. And so our x-axis looks like we're going to start at 0, and then we'll go to pi over 4, and then we'll go to pi over 2, 3 pi over 4, pi, right, 5 pi over 4, 3 pi over 2, and finally 2 pi. That should be enough for us to see what's going on here. Let's use a different color here. Oh, and then on the y-axis, it looks like our highest value is 1. So let's make this this is a 1, and then we'll make this -1. All right, so now let's use a different color to graph this thing. So first value is 0, 0. So that's right here. Boom. And then we got pi over 4, 1. And then this next one is undefined. Okay, so that's the classic case of an asymptote. We learned that from our previous studies. 3 pi over 4, it's down here at -1. Pi, it's at 0. 5 pi over 4, it's at 1. And then again, another asymptote. Those are dotted lines here. And -1, back to 0. Okay, to me, it looks like this is a pattern, right? It looks like there's this line right here, and then it reaches, and there's in between two asymptotes, and then it repeats. If I had to guess, I would guess if I continue to rotate another 45 degrees, it's going to be here. And we know that. That's coterminal. It just keeps rotating, and then this is going to be an asymptote. So I can kind of identify a couple things. I can identify that this graph repeats, but it repeats a little bit differently because it has these asymptotes. Now, here's what we know about asymptotes, that as x increases here, it gets closer and closer, but it doesn't touch this. So this value is getting closer, but it never touches it. So this is definitely a curved line, and we can see that by looking at our unit circle values and finding some tangent values in between here. And the same thing here. I know that this touches it, or it gets close to it, but never touches it. So this is what this particular cycle looks like. And then it just repeats. Goes through that point and gets close to that asymptote. Same thing here. But the thing that's a little weird is, what about this? Does it really just start like this? And I don't think it does. If we look back at this unit circle and we think about, okay, what if these are negative values? So if these are negative values, this would be negative pi over 4, negative pi over 2. That just means it's a negative rotation. So I'm thinking about now going this direction, negative pi over 4. What is the tangent value? That's at -1. So that's here. Go to a negative pi over 2. That's here. -1 over 0, which is undefined. So it continues the pattern just in this direction here. There's an asymptote. So here we go. Boom. Now, what we have here, this is what our tangent graph looks like. It looks a little bit strange. It looks completely different than our sine and our cosine curves. Couple things to think about here. The tangent graph, when we are going to do one complete cycle, the easiest thing to do is to draw this cycle that's split by our y-axis. And so if I can eliminate all of this stuff, I only need one cycle. So for today's homework, all we're going to need is just this cycle right here. We know it's periodic, so we know that at any moment we could create the rest of it, just like we talked about, or for what we need, we're just going to ask that you guys do one complete cycle. Okay, to do one complete cycle here, here's what we need. We're going to need a couple things, and I'll write them off to the side here. So there's 5 things for one cycle. Number 1 is we're going to find 2 asymptotes. And to find the asymptotes, this is what we're going to do. They occur at 1/2 multiplied by the period. Now, we didn't talk too much about that, but the period is this length from here to here. So how do we find the period? The easiest way to find the period on any tangent graph, because here I would have to go, I'd find this distance from -pi/2 to pi/2. So 1, 2, 3, 4 units. Each unit is worth pi/4. That's 4 pi/4 units, or pi units long. But the easiest way to find the period is to take pi divided by the frequency. And the frequency is this value right here. That frequency is the same that we would use a number there for sine and cosine. In this example right here, what I would do is I'd take pi divided by this value, which is 1, and that's why this period length is 1. Okay, so the asymptotes occur in this example not at the period length, they appear at 1/2 times the period length. So if the period length is pi, to find these asymptotes here, we take pi times 1/2, or 1/2 times pi, and that's where the asymptotes occur at intervals of pi/2. -pi/2, pi/2, 3 pi/2, so on and so forth. The second thing we need to do, so this gives us 2 asymptotes. Then we need to find these 3 points. So I'm going to highlight them for you here. So the 3 points we're talking about are this one, and then our high and low guides. So to find those points, so first of all, let's call this one the origin, or midline. You could kind of say it's like the middle of the graph right here. That occurs at 0, right? When the input is at 0, it occurs at 0. And we're going to keep these pretty mild here in pre-calc. That'll change a little bit depending upon some of our other transformations. And at intervals of the period. And that's why you can see it occurs at 0 or intervals of the period here. And that's why we had another one here and then another one here. These are intervals of the period, pi, 2 pi/2, so on and so forth. And the same thing could be true going this direction. 0, -pi, -2 pi, so on and so forth. Okay, another way to compute the other 2 points, so we're going to call these other 2 points our high and our low guides. To compute these high and low guides right here, down here, and here, what we're going to do, they occur at 1/2 multiplied by the asymptote. So if I can find the asymptote, in this case is pi/2, and then I take 1/2 of that, that's going to be pi/4. So they occur at intervals of pi/4. There's your high guide, and here's your low guide. And now the only other thing we're going to talk about is then how high and how low do they go? Well, that depends on this. It depends on this value that we see here. If there's a vertical stretch, and if not, if you don't see any number, then they occur at 1 and -1. Okay, so it seems like a lot going on, but it's not quite as much as you think. That's the basic overview of all tangent graphs. So we're just going to do a couple examples, and we'll have you try a couple. So here we go. Step 1, what I do is I like to find the asymptotes. And I find the asymptotes by doing this. First of all, I got to find the period, which is pi divided by the frequency. In this case, it's pi divided by 1. So the period is pi, and the asymptotes occur at 1/2 times this period. So they occur at pi over 2. And there's two of them. And again, it's every interval of pi over 2. The next thing I'm going to do is going to find my high, low, and my origin guide. And I'm only going to complete one cycle for you guys. So as I'm drawing my scale here, I need a x-axis. I need a y-axis. Sketch that out, and then let's go and let's label these. It's important that they must be labeled. Okay, so on my x-axis, I have an asymptote at pi over 2. I'm going to skip a line for right now, and I'm going to label this pi over 2. Skip a line here, label this negative pi over 2. So at these intervals, I know I just learned those are my asymptotes. Now the next thing I'm going to do is I'm going to find my points. One of those points is at 0. Occurs right here. I have my midline, my origin occurs just right in the middle here. That's where it starts. And it's actually, that's right where the middle of this cycle is. And my high and low guides, here's what they occur at. They occur at 1/2 times the period. So the period was found up here, 1/2 times the period. It's pi over 2. No, I'm sorry. Let's go back. That is incorrect. They occur at 1/2 times the asymptote. So we're going to use this value here. So 1/2 times that is pi over 4. That's why I skipped the line right here. Let's mark these. Pi over 4. Pi over 4 negative. And so then my high point occurs there. And this value right here tells me how high my high guide is. Since this is a value of 2, my high point is at 2. And then my low point is at negative 2. And so that's these values. And then the last thing I do is don't draw a straight line. This bends. And then this bends. There we go. That's one cycle. Our last example I want to do before I ask you to do a couple looks like this. Start off by finding the asymptote in this problem. To do that, I need to find, I'm going to find the period first. Oops. My period for this problem is pi divided by the frequency. So I've changed the frequency in this problem. In this problem, the frequency is 3. Whatever number you see here. That makes this period pi over 3. So to find the asymptote, what I'm going to do is I'm going to take 1/2 and I'm going to multiply it by this period length. That makes the asymptote pi over 6. Before I get going any further, I'm going to start to create my graph here. X-axis, y-axis, and then what I like to do, I like to draw that first cycle and have it be split between the positive and negative. So I like to skip a line here. I'll label this. I'll go my intervals of pi over 6 to put my asymptotes, and then I do the same thing. I go backwards and draw this asymptote. Now, technically, you could either draw this cycle, or you could draw the next cycle, or the 3rd, or the 100th cycle. It doesn't matter. It's just the easiest one. The reason why that's easy is that this cycle always starts right here. The first one is at 0. The next 2 points, we're going to have a high point and a low point. The high points occur at 1/2 times the asymptote, which in this case is pi over 12. So that occurs right here. And if I skip a point, then these are in the same unit increments here, which is kind of a little savvy move. And then how high do they go? I use this number to see if there's a vertical stretch. If not, they just go 1 unit high. So this would be right here, 1 unit. Make sure you label, and then -1 unit. So 1 unit high as I go to the right. If I go backwards, I'm going to go down 1 unit. There we go. Make sure you draw this as it bends, as it relates to the asymptotes, and there's one cycle of the tangent graph.